okay, so now that we have looked at all of these building blocks, now let's see how we can start putting these together a little bit more. So now what we're going to do is we're going to write a little bit of a SAS macro program here. And I'm going to go back to SAS, and we're going to run this stuff. So first off, here's the section that we're wanting to be in. I'm going to create these little fake data files here. This isn't really part of the seminar. It's just creating some data for us to work with. We're going to have 4 files here, file 1, file 2, file 3, and file 4. And if I look at the log file here, we go, okay, great. We've got these 4 files, each of which have got 3 observations in them. Now, the reason I'm making these, because I want to show an example of what if you wanted to write a data step where you wanted to read in a whole bunch of files. So in this example here, we're saying data all set file 1, file 2, file 3, file 4, of course a concluding semicolon, and then a run statement. Well, if we run this, we go, okay, that's some pretty simple SAS stuff, and I don't mind typing in file 1, file 2, file 3, file 4, but imagine like we had a client who had 1,000 such files to be read in. You might not be so content to read in 1,000 files or to type 1,000 file 1, file 2 up to a file 1,000. You might be looking for a shortcut, and using a SAS macro is a great way of making a shortcut for that. So even though we're going to have just 4 files here, always just imagine we've got 1,000 of them. So here's our first little macro program, and this macro program is called combine. That makes sense because this is going to combine a whole bunch of files. It starts off with %macro and then the name of it and then a semicolon. So this is telling SAS, I'm defining a macro and this is the name of my macro. This is the contents of the macro, and then here you end it with %mend for macro end. Sometimes I say %mend, which makes me think that it's like broken and I need to mend it. And then it concludes with a semicolon here. So that's our basic structure of defining a macro. So let's see what we're defining here. What I'd like to do is make this window larger so we can compare the macro we're defining with our original program here. So here we're saying data all _1, just to give it a new file name as compared to this data all. Set, same as the set. Now we've got file 1 up to file 4. So what's the pattern here? That each of these start with file, but they go from 1 to 2 to 3 to 4, incrementing in ones. That's what this %do does. So %do I equals 1, %to 4, semicolon, file, and %i. So, and then %end, semicolon. So this is a loop, and it's going to do this loop with I being 1, then 2, then 3, then 4. Every time it does this loop, if we go file %i, it'll be file 1, file 2, file 3, file 4. Then it will fall out of the loop. Then it will do the semicolon, then the run, and then we're done. So you can see here it's set, file 1, file 2, file 3, file 4, the semicolon, then the run. So it looks like this macro is a shorthand way of doing the same thing. So let's give this a try here. Let's define this macro. So I hit F3, and what I'm going to do is I'm going to shrink this back down again. And we see in the log file, it doesn't look like very much happened, but a lot did happen. This macro got defined. But when you define the macro, it doesn't actually do anything. To actually run it, you have to call it. And when I call it, I say %combine. I'm going to hit F3, and I look at my log window. And in my log window, %combine, hey, it looks like it did what we wanted. It read in file 1, file 2, file 3, file 4, and the file all _1 has all 12 of the observations. However, I can't really see what it did. I just see kind of the consequences of what it did. So if I use this options mprint and then run this, what it will do is it will show me the actual statements that it executed when it executed the macro program. So I'm going to try running this again. And then if we look up here, so here's the options mprint that I ran. Here's the percent combined. And then here it's showing me, mprint combined. These are the statements that derived from running combined. Data all one, set, file 1, file 2, file 3, file 4, the semicolon, and then the run, and then here's the consequences of running that. So this mprint can be very useful. So running a macro isn't like running a black box and you can't see what's inside of it. Now looking at this, you might go, was this semicolon really necessary? Did we really need that? I'm going to delete that semicolon. I'm going to try redefining this macro by running this. Now I've given it a new definition, which now doesn't have the semicolon. And now I'm going to run the percent combine again. So I run that macro, and it looks like we've got a little problem here. And here it shows us data all one, semicolon, set, file 1, file 2, file 3, file 4, run. Whoops. We didn't have that semicolon right here, which said, we're at the end of the file 1, file 2, file 3, file 4, and before the run. So we get the message work.run doesn't exist because it's thinking that this is part of the set statement. So that's why we needed to have that semicolon right there.
Yeah, you can see that the data step is still running.
Oh, yes. See, we're not even done with our data step here. So if we want to conclude it, we need to get a run statement in there. So I'm just going to mark this, and then that finished off the data step. Oh, very good. So now...
By the way, when you call your macro program combine, you don't have semicolon at the end.
Oh, that's a very good point. That why don't I have... Now, I could put a semicolon there, and it would be okay, it would be permissible. It's just not necessary. Because when we run combine, let's run it again. So let's scroll up here, and then let's define it again properly with that semicolon in place. And then let's run it again. So when we execute it, we see that this is when it does the substitution. And when it does the substitution, here's the data step, here's the set, here's the run, here's the semicolon on the run statement. And if I put a semicolon here, it's kind of like putting a semicolon right here, and you go, I don't need to have two semicolons at the end of a run statement, so that semicolon isn't really necessary. So when you think of macro statements like this percent combine, when you're calling a macro, think about the substitutions that it's making, and then after it makes the substitutions, do you really need a semicolon there? And the answer is no, you really don't. If it makes you feel better, you can put them there, and it won't hurt anything. It would be very much like if I put a semicolon like right here, that extra semicolons in SAS in between statements don't harm anything. However, if I put a semicolon, just to be clear here, if I put a semicolon like right here, that's a problem because that gets in between two statements. So enough on SAS and semicolons. One thing we didn't do yet was we just assumed that this worked properly, but we can check it using this proc print statement. And here with the proc print, we go, okay, it looks like that macro read in all the data, and here with the proc print, we could double check and see that it was coming in fine. Now that previous combine macro was kind of a nice macro. I liked it. The only thing is that it assumed we were always reading in 4 files. Maybe we're not always going to read in 4 files. Maybe we want to read in a different number of files. Here's a modified version of macro combine. And notice here on this do statement, Previously where we had 1 to 4, now we say 1% to ampersand num. Oh, this looks like a macro variable here where we could run this do a different number of times. But where does this ampersand num come from? Well, if we look up here, oh, it comes from here. Oh, well, that doesn't seem to really answer things. Well, where does here come from? So in the definition of combine, we seem to be defining num here. Well, really what it's saying is that when we run it, we're going to pass in a parameter which is going, so this 3 is going to get passed into num, and then when num gets evaluated here, in this example, it would get evaluated to 3. So if we define the macro here, so now it's defined, and we can look at the log window and see, okay, it's defined. Now let's run it. And we look at the log window, and it read file 1, file 2, file 3, and here we can see here, it data big, set file 1, file 2, file 3. Great. Let's try it again, but let's just try passing in 2. So we run this, and then we look here. It did set file 1, file 2. So this value of %num, which it derives from here, allows us to control the way that this macro behaves. It's a little bit more customized. Now there's a little bit of a problem with this macro, is that it only allows us to do numerical sequence values, and we'll see examples a little bit later that are a little bit more flexible.
But now you can do 1,000 files.
Exactly. Thank you for bringing that back. That's the idea. So this macro, as long as the files are named file 1 to file 1,000, I can change this to %combine 1,000, and it'll read in 1,000 files with just the same amount of difficulty or ease of reading in 3 or 4 files. Excellent. So let's build up a little bit of a fancier macro. This previous macro that we were looking at was repeating steps, repeating statements within a data step. Now what we're going to do is do a macro that repeats statements, repeating a proc step, doing a procedure step over and over and over again. And we're going to do this using this little fake data file here. So I'm going to read this data file in. And you can see that this data file has variables named v1 to v5, and these variables are just dummy variables. And then we've got 2 independent variables here, int1 and int2. And let's say that we do a logistic regression predicting v1 from int1 and int2. So we do proc logistic data equals xxx, the name of our data file. Of course, we remember the descending option, and we're going to run this, including that title statement there. And we look and we go scrolling up a bit. And here it looks like we've got our, we're working on work.xxx. The response variable is v1 and so forth, so we're getting some results here. That's nice. But what if we wanted to do this for all 5 variables? Well, you might go, oh, I know what we'll do. We'll go v1, v2, v3, v4, v5. We'll do it right here within proc logistic. Is that going to work? So we'll try running that, and we look at the log, and it seems that SAS is kind of complaining about this. This isn't a valid syntax for proc logistic. If we want to run these 5, we have to either do separate model statements or separate procedure statements to do all of those 5 different runs. This sounds like, again, a great case for doing a macro for this. So scrolling up here we're defining a macro called mylogit, and we're going to pass in a variable num. And we're going to say do I equals 1 to num, and then we're going to do these statements, and then have a %end, then a %mend to end the macro. So what are these statements that we're going to do over and over? Dependent variable is v ampersand I. So the first time this would be v1. Proclogistic data equals xxx, descending option, just abbreviated. Model v ampersand I. The first time it does this, this will be v1. And then run and then end. So this will do this for however many times we specify num to be. If we specify 3, it will do v1 up to v3. Down here, we're going to pass in 5. So if we first define this macro, and then I'm going to scroll this down a little bit here, and then scroll this down here, and then if we run it passing in 5, ooh, it just ran and ran and ran and ran. And now if we look at the log file here, we scroll up, scroll up, scroll up. I should have probably cleared the log, but here we can see that here's where it starts, and here it's running it for v1. Here it's running it again for v2. Then for v3, ooh, we're getting a warning here. We'll look at that a little bit later. This doesn't have anything to, well, no, let's look at it right now. That there's complete separation of the data points. This is not a problem with our macro. This is a problem with our data. That this is saying that we've got complete separation and the logistic model might be invalid. This is an important thing because even if you automate the process of running 5 or 20 or 50 logistic regressions, it doesn't take away from the fact that you still have to make sure that each model is valid. Here we see it for v4, and then here we see it for v5, and then it's all done. And if we look at the output, we could scroll through this output, but trust me that we've got the results for each of them. And we see dependent variable is v5. That derives from this title statement that we did here, so that helps us see which output corresponds to which variable. So that's a pretty nice program to allow us to run these proc logistics over and over again. But there's a little bit of a trouble with it, and that is that, I'm ahead of myself here. Before we get to that trouble, we're going to look at an option here called mlogic. And this is a very handy option if you want to debug your macros. Sometimes you might write a macro and you don't think it's functioning properly and you want to understand better what it's doing, and mlogic will help you do that. Mlogic stands for macro logic. So this macro is the same as above, but we've also put in this %put_i to help us see a little bit about what's going on inside of this. So what I'm going to do is I'm going to set this option, define the macro, and run the macro all in one step here. So I'm going to hit F3 to run this. And now I'm going to look at the log file. Actually, I'm going to clear the log file, and then I'm going to run this again. So we'll see it from a fresh log. So here in the log file, I'm going to go up to the very top. And here we've defined the macro. And now you can see here's where it's being called. And then the mlogic says it's beginning the execution. Okay, the next step. Parameter num has a value of 5. Good, we passed in 5. Now the next step, after it defines num, now it's going to do this the %do. %do loop is beginning. The index variable I has a starting value of 1. That's what we told it. A stop value of 5. That's what we told it. And it's going to increment by 1s. Great. So now it's done this do. Now it's going into the title and the rest of this. So here is the title, the proc logistic and the model statement and the run. Here we can see the results of running this. And now %do loop index variable 1 is now 2. The loop will iterate again. Okay, so now our do, going through this do loop, I is now 2, and the loop will iterate again. And here it does it again. And I'm going to scroll through, not making us go through all of these. The do loop I is now 5. The loop will iterate again. It does it again. Now it says the do loop index value I is now 6. Loop will not iterate again. And then it does this percent put I. It shows us indeed it is 6. And then the macro is all done. So this shows us more about the logic of what it's actually doing.
So if you see the percent put statement here, even though I, when you don't specifically define it, it's actually a macro variable inside your macro program. This type of variable is local macro variable. Compared with what we use let define outside the macro program, those are global macro variables that they can be used anywhere in the entire session. But this I is very short-lived, so you only see it within the program.
That's a very good point. So if we did a control C here and then we did this and put it down here, and I won't actually do it, but if I ran this macro, so if I defined this macro, ran it, and then afterwards did this percent put I here, I wouldn't see 6. I wouldn't see this because the life of this macro is only while the macro is running, and then when it's all done running, it disposes of that macro, the I macro variable, because it doesn't need it anymore. Very good point. So now we're going to move on to a modified version, and what this modified version is going to allow us to do is to specify any arbitrarily named dependent variables. Previously they had to be named V1, V2, V3, and so forth. That's very restricting, that you normally wouldn't name your dependent variables that way, that your dependent variables might be named read, write, math, science, social studies, that they all have different kinds of names, and this kind of macro will allow us to do it. For that extra generality, though, it's going to be a touch trickier, but we'll walk you through it. We're going to start by defining our macro, and then we're going to pass in something called all-deps, the name of all of our dependent variables. We can call this anything we want. It's not a magical name. It's just the name like we had before called num. Now what we want to do is we want to work across all of these dependent variables starting with the first one. So we're going to say percent let k equal 1. K is going to be our counter counting up which of the dependent variables we're working on. And then we're going to say percent let dep equal scan. That scan function, remember that scan function we saw before? It allows us to take this macro variable and pick off this word, the first word, the second word, the third word, from that list. So this has got the list of all of our dependent variables, and the first time we run this, k will be 1. It'll pull off the first dependent variable, the first word. Then we're going to say, now we want to do this as long as we have dependent variables left. So if we have 3 of them, we want to do it 3 times, and then the 4th time we want to abandon this. So we're going to do this while the value of ampersand dep is not equal to quote quote. So if we get past the last dependent variable here, this ampersand dep will be empty. It'll be a void. So this will be quote quote, and then this will be quote quote. These will be equal, and when we say do while these are not equal, so that condition will then be false. It will drop out, and then we'll be done with this process. Now, what do we do while we have the valid dependent variables? Well, we're going to do all of this stuff. So we're going to say title dependent variable is ampersand dep, proclogistic, model ampersand dep, run. So this part looks pretty much like what we were doing before, but now here we've got some additional kind of housekeeping here. Now what we want to do is we want to increment the value of k. percent let k equal to k plus 1, but what we have to do is we have to use that percent eval function for it to mathematically evaluate it. So after k is 1, it'll become 2, and then it'll become 3, and so forth. Then we say percent let dep equals scan all deps ampersand k. It's going to get the next variable, and then it will go up to here, and then it'll do it again. It'll get the next variable. It'll get the next variable, and so forth until it runs out of variables, until such time that dep is empty. Then that's the end of the loop, and then the end of the macro. So first, I'm going to define the macro, and now we'll call it, and this time we'll call it by passing in v1, v2, v3. We'll just run it for these variables. Now they happen to be all named v1, v2, v3, but now they don't have to be named that. So we run this, we have a look at the log, and we see that it looks like it's run it. We've got so much busy stuff here with the mlogic, and this is why you wouldn't always use the mlogic, because it gives you so much output when you don't necessarily want it. If we look at the output here and scroll, we see here we get this for v3, we get this for v2, we get it for v1. It looks like this has worked. So now with this macro, we can put any arbitrary set of variables in there and it will run properly. So now here we've got an additional modification. In this modification, what we're doing is we're adding the ability to save the estimates into an output data set, so then it's really easy to see a quick summary of the results. Previously up here that we had to scroll through and do a lot of scrolling to see our results. Maybe what you want to do is you just want to capture the estimates and put them into an output data set. So this is what this is going to allow you to do. I'm going to make this window bigger so we can see more of this. Up here, this part should be looking familiar. In fact, this part really hasn't changed at all except for this part right here. So every time we run this in this loop, we're saying out est equals underscore est percent, ampersand k. So the first time it runs it, it'll be underscore est1. The second time it'll be underscore est2, and so forth. This will capture the estimates from each of the runs. Now, if we have some branching here using percent if. So this, we're doing an if-then statement. If out est is not equal to quote, quote. So if this is kind of nothing here, so if this is not equal to nothing, then we're going to make an output data set, and the output data set is going to use the trick that we saw before. First off, the name of it, this ampersand out est, comes from up here. This is where you would have specified if you wanted an output data set and what its name should be. Then, this probably looks familiar. Set do I equals 1 to, oh, this is interesting, k minus 1. We'll come back to that in a second. Underscore est, ampersand I, percent n, semicolon. This is like that trick that we saw before with reading all of the data files. But why did we do k minus 1 here? The reason we did k minus 1 here is because when we go through this loop, if we have 5 dependent variables, this last time that it goes through it, it's going to make k into 6. It's going to be 1 too many. So we need to say, oh, we want 1 less than the value that k had here when it was through with this loop. So this data step right here will make out the file out est based on what the user says here. And then on top of that, we're going to make k equal to k minus 1 and then we're going to do proc data sets, and we're going to delete underscore est1 to underscore est up to k. So because we created this single output data set, we're going to go ahead and get rid of this. Then we have an end. This end corresponds to this do, so this is all the stuff that will be done if you specify a value for outest. Else, if you don't, it's going to put this little message saying no data set was provided, files are not combined. So now we've got a little bit of branching in here. So the first time that we run this, we're going to run this just by specifying the 3 variables, but no output data set.
Have you run it?
Oh, we need to define this first, don't we? So we're going to define the macro, and then we're going to run it. So there we run it, and if we look at the log file here, it says, no data set name was provided, files are not combined. Now, did it create all of those est1, est2, and so forth? So if I look over here in the libraries, and I look into work, and then I scroll down here, and here we go. est1, est2, est3. Those are the data files that it created for us, and it didn't delete them. Now let's try it this way, but now I'm going comma A. This is the name of the data file that I wanted to create with the combined estimates. The comma separates the first parameter from the second parameter. This is the name of the dependent variables. This is the output data set. So we run this, and we come over here to the log window, and we can see a couple things happened here. So we can see that, oops, I wanted to scroll up a little bit more. So here is the data step. I should have done this turning off the mLogic. Here's the data step. Here it's doing the set est1, est2, est3 run, and then we scroll down more. Data set work.a has 3 observations, so it created it. And then we scroll down here, and this is the part where the proc data sets deletes est1 to est3. If I come back over here, that I can see, scrolling up, here's data set A, and then I scroll around looking, where's est1, est2, est3? We deleted them. Now I can do this proc print, and here for this data set here, here's the first run that we did, here's the second run that we did, here's the third run that we did, and here we've captured all the results. But one of the things that I want to caution you about this, it seems like, wow, we just ran it all and then we got the results. But remember that from our log window up here, scrolling up, in this third run, we had the complete separation, and the fit of this model was very questionable. There's nothing in this that jumps out and tells you that there was a potential problem with this model. So don't get a little bit too casual about automating processes using SAS macros. You still need to do all of the kinds of data checking that you've done in the past. Now, this last example was very nice, but here we've got an even better example. In this example of this macro, it allows us to specify lots of options. We can specify the name of the data set that we're wanting to analyze. We can say the name of the dependent variables, one or more dependent variables. We can specify the independent variables. We can specify whether we want an output, what we want the output of the output data set to be called. These two parameters are a little bit different than these two. These two parameters are positional parameters. So the input data set is in the first position. The dependent variables are in the second position. These parameters can be specified anywhere thereafter, and they're specified using the equal sign. Because their position is more arbitrary, you need to use the equal sign to say which parameter am I talking about. So down here, when we call this is the data file XXX. These are the variables v1 to v3. The independent variables are equal to this. The output data set I want to create is equal to this. And I could specify these two in any position that I want to. So that's one notable difference here. Now let's see how this kind of plays out. This part is the same as before. Now we're saying this is basically the same as before. This is just specifying an alternate syntax of saying while dep is basically empty. We're saying here is the title statement. Here's the another title statement telling us about the independent variables. Proclogistic data equals in data, because that's the data file that we've passed in. And then outest equals est ampersand k, just like before. And then on the model statement, we're deriving the dependent variables from dep, like we did before, and we're deriving the independent variables from this, which is getting passed in up here. We're doing the same trick as we did here before, and then we're doing the same trick like we did here, except now we're doing it kind of unconditionally. We don't have a condition saying whether we want to do this or not. We're always doing it. Now, when we're always doing it, how do we know what the data file name is? If somebody doesn't pass in a data file name through myout, it'll be called _out. If they specify something different, then it will give it the name that they've specified. So this first time, we're going to call it myout equals myparms. So I'm going to run this. Oops. Apparent invocation of macro mylogit A is not resolved because I forgot to define it. So I'm going to go up here. I'm going to define the macro. And then, now that I've defined it, now I'm going to run it. So now I execute the macro, and then if I look over here, I'm going to see that I have got myparms. So that's where it put the output data set into myparms. And then here I can do this proc print, and then there we see the results from what we've passed into it. Now, what I'm going to do is I'm going to, just for fun, I'm going to take this myout out, and then just run this. And then if I come over here, here we see _out. That's what it created because I didn't give it the name of the output data set. So now, here's another example. Here we've switched the order. So myout comes first, int vars comes afterwards. So I can run that.
You also use different data set.
Oh yes, I've used a different data set here. Now I've used the HSB2 data set, and I've used female as my dependent variable.
Right.
And then these are my independent variables, exactly. And then here I can do this proc print, and then here we can see the output from that. We just did one dependent variable here because we only had one binary dependent variable in that example. So this is actually a pretty neat general program that allows you to run many logistic regressions on the data set of your choice, with the dependent variables of your choice, with the independent variables of your choice, and then outputting the results to whatever data set that you want. So this is, without too much effort, we created a macro program that was actually pretty darn useful. So we hope that this has been a nice introduction to you for learning about SAS macro programming. And we know that this isn't the be-all, end-all of introductions, that there's probably more things that you're going to want to learn. So we'd suggest one place to go is our links by topic page on programming. So this is programming within SAS, and that there are all sorts of examples here. And probably the section that would be most relevant here would be the section on SAS macros. And then there's all sorts of other things that might be useful here as well. And then we have these other links that we'd also refer you to learn more about programming in SAS macros. So we hope you found this useful. You want to say farewell?
And thank you very much.